3.1, reciprocal of a linear function. So you know the linear function is like what? 2x minus 3, y is equal to 2x minus 3 is a linear function. When I say reciprocal of that, basically you just flip it over, right? You say 1 over 2x minus 3. So this is a reciprocal. Of course, you know that the drawing for this is a line, is a linear like that. A drawing for reciprocal is different. You have an asymptote. So I'm gonna do an example with you. I'm gonna clear that. Let's say I wanna draw f of x is equal to 1 over 2x minus 1. Then I wanna talk about domain, range, and end behavior. Let me just bring a white board here. So I want to draw y is equal to 1 over 2x minus 1. So first things, there is a restriction. You know the denominator cannot be 0, right? So the zeros of the denominator is restriction, 2x minus 1. If you equal it to 0, 2x equal to 1. X equal to what? 1 over 2. So this is restriction. Restrictions means x cannot be what? X cannot be 1 over 2. This is my restriction. How about for y restriction? Look at numerator is 1, right? So just a little note for you. If a over b is 0, you will conclude that your numerator is 0, right? Numerator should be 0. From that, you can conclude if you have a ratio a over b 0, the a for sure need to be 0. But look at that. Your numerator here is always 1. It cannot be 0, right? It never will be 0. Means y never will be 0 because numerator is a fixed number. For a ratio to be 0 means your numerator should be 0, right? So the y cannot reach 0, never. So this is a restriction. This is the restriction for y. Restriction of y value. From these restrictions, later on, we can do the domain and range, okay? Now, you find the restriction. From the restrictions, you can find the asymptote. I'm gonna do a different color. Here, we have horizontal asymptote. Horizontal asymptote is the line of y equal to 0. Means your graph never passes this line. And from x, you have a vertical asymptote, which is equal to x equal to 1 over 2. Means your graph never pass x equal to 1 over 2. If I graph, maybe I just put the graph here. I'm gonna show you the asymptotes. Here, horizontal asymptote is the y equal to 0 is this line, the horizontal line, right? Just coincide with your x-axis. We call this one y equal to 0 line. Horizontal asymptote. Vertical is x equal to 1 over 2. If this is 1, here is 1 over 2, right? So this is going to be your vertical asymptote, which is x equal to x equal to 1 over 2. X equal to 1 over 2. So there are other things I can find, right? Like what? X-intercept. To find x-intercept, we put what? Y equal to 0. Okay. Okay, Brian, we're graphing this y equal to 1 over 2x minus 1. I'm going to explain a little bit more. What we did, we said that in denominator, we cannot have 0, right? 1 over something in denominator, 2x minus 1 cannot be 0. So to find a restriction for x, we put the denominator equal to 0. We solve for x. So the restriction for x is going to be 1 over 2. Also, the restriction for y, look at that. The notation I put here. There, if you have a ratio a over b equal to 0, of course, a should be equal to 0, right? But here is y equal to 1 over 2x minus 1. Your numerator is always 1, is fixed. Your numerator never will be 0. That's why the y never reach 0, because your numerator is fixed and 1. So y cannot be 0, or this is the restriction for y value. From restriction from y value, we can have horizontal asymptote, y equal to 0. And vertical asymptote is a restriction for x equal to 1 over 2. Y equal to 0 is a line, is a horizontal line. See, I put it there. And for vertical asymptote, x equal to 1 over 2. So this is line of x equal to 1 over 2. The graph never passed these two lines. Did you understand, Brian?
Yes.
Okay. I'm going to continue to find x-intercept. For x-intercept, you need to put y equal to 0, right? Can we have that? No. Again, see there, 0 is equal to 1 over, so the numerator is fixed. You never have an x-intercept. How about y-intercept? For y-intercept, you put x equal to 0. So y equal to 1 over 2 multiplied by 0 minus 1, which is negative 1. So I have that point, y equal to negative 1, which is here. This point is my y-intercept. Okay, I need another point to graph that. See, it's good that I put a point above and below this. Let's say I can find for x equal to negative 1, right? And when my x is 1, and when my x is 2, you need to have 2 points above this vertical line. 1 over 2 above that is 1 and 2, right? So for negative 1, if you put your x here to be negative 1, what would be your y? The y would be 1 over 2 multiplied by negative 1 is negative 2. Minus 1 is negative 3. So it's going to be negative 1 over 3. If you put 1 here, 2 minus 1 is 1. So 1 over 1 is 1. If you put 2 here, 2 multiplied by 2 is 4. 4 minus 1 is 3. So 1 over 3. These points are enough for me to graph it. So here, negative 1 over 3 is approximately here. This point, negative 1, 1 is 1. This there. When it's 2, it's 1 over 3. I'm just connecting the point. Please be careful. When you connect these 2 points, You have to continue. You have to go toward asymptote, but never reach it. From this side, you go toward the asymptote, but never reach that. You connect these 2 points, you go toward the asymptote, but never reach that. Going toward asymptote, never reach the asymptote. Any question about the graphing? Theodore? Carlos?
No.
No? Okay, for domain. Domain is restriction for X, right? Is X, ER, X belong to all real number. X cannot be what? 1/2. So for the restrictions of the X. For the range, is the restriction for Y. Y belong all real number. Y cannot be what? Can anyone tell me? Ryan? Can anyone tell me Y cannot be what number? What was the restriction for Y? Here. 0, right? Y cannot be 0.
0. Oh,
Yes. Now, end behavior. End behavior. I'm going to ask you, when X go to positive infinity, where does the Y go to? Anyone can tell me? When X go to positive infinity, where does the Y go to?
X 是加化 Y， 我想想 ，X 加 X 加什么？positive
Positive what?
positive positive
Okay, let me explain that. Yeah, see? When X go to positive infinity, you have to look at this end, right?
Yeah.
When X go to very big number, the Y getting close to what number? 0, right?
0.
0. And this is gonna be 0 positive. Okay. And here, can you tell me when X go to negative infinity, what does the Y go to?
0 negative.
Very good. See, the Y getting close to 0, but from negative side, right? Now, tell me, when X gets close to 1/2 from positive side, what is the behavior of the Y?
-加的话 ，Y 是 it's a positive 2.
See, 1/2, right? If you get into the -2, if your X getting to 1/2 from right side, your Y, you have to look at this side of the graph, right? Your graph go very high. It's like positive infinity, right? Can you tell me even the X go to the 1/2 from negative side?
Negative.
Negative infinity, right?
Infinity.
Exactly. So your graph, your X getting closer to 1/2, look at your graph going very down to negative infinity. Can you take a screenshot of that? Brian, did you understand?
Yes.
Okay. Can you take a screenshot, everyone, and let me know?
Oh, I did it.
Yeah.
You did? Okay,
Yeah.
thank you. All right. I'm gonna go to the notes again. See, this is what we did. Here is another example that I can try to graph. Let me see this example. That would be very similar, but you have it to add this things. Now let's just go to the worksheet. I'm gonna give you questions to do. This is worksheet 3.1, okay? You do number 2. Number 2, the second part. So 2, I. So you need to write an equation for that. I'm gonna do the first one for you guys, so you can have an idea how to do the second one. But let me first say what you need to do for this homework. Number 2, second picture. Okay. Number 3, A and C. I'll do B for you, okay? And question number 4, do B and C. I do A for you. And you do number 6, number C, and E. We did an example of that, those graphing and drawing. So, and number 7 and 8, very important questions. 7 and 8. I'm looking for a 7 and 8, guys, but definitely I'm gonna explain it in class, right? Because they are such important questions. Try to do it. Okay, let's just, I'm gonna explain those questions for you that I did, promise. So first question I wanna show you is this one. Write equation to represent the horizontal and vertical asymptote. Okay, see here my vertical asymptote, right? Which is x equal to what? X equal to 2. And my horizontal asymptote is the 1. So how do I know? Because my graph is just going toward it. Is y equal to 0. If this is like that, then yeah, it's just for A, you just need to write horizontal and vertical asymptote. For second question, write a possible equation. Since my horizontal asymptote is y equal to 0, this is in this form, y is equal to 1 over, this should be fixed because y never will be what? Never will be 0, so it should be fixed. For that, I put it A because this could be any number. I put it as A. But in denominator, going to be a restriction for x, right? I need to put x minus 2. X minus 2, the zeros of denominator is going to be x equal to 2, which is my restriction. Now I need to just figure out this number. To figure out this number, you just find a good point on your graph. Let's say this point, right? What is this point? Is 1. The x is 1 and the y is approximately 1 over 2, negative 1 over 2. I'm gonna plug this into this equation and to figure out what should be A. For y, I put -1/2. I don't know A. For x, we put 1. 1 minus 2. So I'm gonna rearrange it. Equal to A over -1. So -1 to the other side become A is equal to 1/2. Then you have to rewrite your equation. So then my equation, I got A equal to 1/2 x minus 2. Everyone got that? Ryan and Tudor?
Yes.
Would you please take a screenshot of that so you have it so you can do the second part for me?
I did it.
Perfect, thank you. The next question. I told you I'm gonna do that. So here I'm gonna do A. Write equation to represent the vertical asymptote. Vertical asymptote is restriction for x. So x minus 5 equal to 0, x equal to 5. So this is gonna be my vertical asymptote. This is part I. Write equation to horizontal asymptote. For horizontal asymptote, because my numerator is fixed, you automatically, you will say that the y cannot be 0. So y equal to 0 is my horizontal asymptote. Determine the y-intercept. For y-intercept, everyone knows that for y-intercept, we need to put x equal to 0, right? Y equal to what? 0 minus 5, -1/5. This is gonna be my y-intercept. So can you take a screenshot, everyone? And let me know so I can move on.
Yeah.
Done, okay, thank you. So this one, I'm gonna do A for you, the same thing. First, you have to do the vertical asymptote. Vertical asymptote, see here is each unit of that is 1, 1, 2, 3. So x equal to 3. Here's my vertical asymptote. And y equal to 0 is my horizontal. Again, y equal to, I don't know what is the A here. I know denominator should be x minus 3. Your restriction for x is x equal to 3. So the zeros in denominator should be 3. And I need to find a good point. The good point here is here, which the x is 4 and the y is 1. So y, I put it 1. 4 minus 3 is 1. So a is equal to 1. I need to rewrite my equation. Y equal to, instead of the a, I put 1. X minus 3. Would you please take a screenshot and let me know you done?
I did it.
Perfect, thank you.
Yeah.
So sketch the graph. I did this sketch the graph. And I'm looking for 7 and 8, guys. Do it. We'll discuss that later. So again, I'm gonna give you half an hour and I need to teach another topic as well, right? Please be here on time so I don't have to reteach everything. You got it?
Yes.
Okay, perfect. You have to log in as well.